All right, we are going to do a little bit of algebra review. So you should have this worksheet, and we are going to use this again later after spring break, so make sure you hang on to it. We're just going to look at the first page today, and we're going to do the second page when we come back from spring break. Okay, so we want to review solving quadratic equations, which we've done a little bit of this year, but not a whole lot. So we're just going to review that. So the first section is to practice solving by factoring. So we have an equation written like, like this, and our goal is to try to factor the expression on the left side of the equals. Okay, and then because we will have a product that equals 0, we can use the zero product property. And we know if two numbers or more, if two or more numbers are multiplied together and the product is 0, then at least one of those factors had to be 0. Okay, so that is a very powerful property and allows us to solve equations. So let's look at how we might go about factoring this x squared minus 36. Well, this is a special pattern that we should have seen when we were in Algebra 1 called a difference of squares. So this is a difference of squares. Okay, and what that means is we can see that this is a perfect square, x squared, and 36 is also a perfect square, it's 6 squared. So we have a difference, a subtraction, of two perfect squares. Whenever we see a difference of squares, we know that it factors into the square root of the first one, in this case is x, minus the square root of the second one, that would be 6, and then an x plus 6. Okay, so we have different signs in between and use the square root. Okay, now let's see, kind of foil this out and figure out why this works. So we have x times x, that's x squared. And then we would have 6 times x, that's 6x. And then we would have minus 6 times x, that's negative 6x. So when we have 6x minus 6x, that goes away. So we just are left with 0 there. And then we have the minus 36. So when we FOIL that out, we'll get x squared minus 36. So as long as these are different signs, those middle terms of the FOILing will always drop out, and we'll just be left with the square of the first one minus the square of the second one. Okay. So now we can use the zero product property. So I have a product. Okay, the product is 0, which means the first one, x minus 6, must have been 0, or the second factor, x plus 6, must have been 0. Okay, so solving this equation, we get x is 6, and solving this equation, we get x is negative 6. So this equation has two solutions, positive 6 or negative 6, and we can verify that that works. If we had a positive 6 squared is 36. 36 minus 36 is 0. That one works. What about the negative 36? Negative 6 squared, that's negative 6 times negative 6. That's positive 36 minus 36, also 0. So both of these solutions work. Okay, good. So let's move on. Now we have x squared plus 9x plus 18 equals 0. So once again, we know we want to solve by factoring. And so this time, it's not a difference of squares like this. This is a trinomial. And trinomials, I usually just like to write myself two sets of parentheses. Okay, so to get the x squared, I'm going to put 1x here and 1x here. And then I ask myself, what numbers will multiply to 18 and add up to 9? So they have to multiply to 18, be factors of 18, and then they have to sum to the number 9. Okay, so if we think about the factors of 18, we have like 1 and 18, we have 2 and 9, we have 3 and 6, and I guess that's it. Okay, so those are our options. Okay, which one of those add up to 9? Well, clearly it's the 3 and 6. So we could put a 3 and a 6. And then you could check it real quickly. X squared plus 6x plus 3x, that's 9x. And then plus the 18, so that works out. Okay, and once again, once we have that factored, we can use the zero product property, so we know that either this factor x plus 3 has to be 0, or this product x plus 6 has to be 0. Okay, this one would be 0 when x is negative 3, and this one would be 0 when x is negative 6. Okay. Let's try another one of those. Okay, so x squared plus 2x minus 24. This one's a little bit trickier because of the negative in there. So once again, it's a trinomial. I'm going to give myself two sets of parentheses. I'll put an x here and an x here. Okay, so we need two numbers that multiply to 24 and add to 2, but because the product is negative here, one of the numbers will be positive and one of them will be negative. Okay. And so if we think about the factors of 24, we have like 1 and 24, we have 2 and 12, we have 3 and 8, we have 4 and 6, and then I think that's it. Okay, and so we would need one of those to be negative, one of those to be positive, and they add up to 2. So essentially their difference has to be 2. Okay, so which of these has a difference of 2? Oh, well, it's this one. 6 and 4 have a difference of 2. Now I want it to be a positive 2. Okay, so I'll need to make the 6 positive and the 4 negative, because 6 minus 4 is positive 2. I need a positive 2. So I'll use a positive 6 and a negative 4. Okay, let's check that. X squared, then we'll have minus 4x plus 6x, that is the positive 2x, and then a negative 24. All right, that works out. Okay, and how is x plus 6 going to be 0? Well, that's when x is negative 6. And how is x minus 4 going to be 0? Well, that would be when x is 4. Okay, so those are our two solutions. Okay, the next one here is a little trickier because we have this coefficient and it's not just a plain old x squared like in these previous ones. Still a trinomial, so I still want to give myself two sets of parentheses. Okay, but this time I can't just put x and x, so I have to think about what would multiply to give me 2x. Well, 2 only has two factors, 1 and 2, so one of these must be 2x and the other one must be x. Okay, but that makes things a little bit trickier because now I can't just do a simple like, oh, multiplies to 3 adds to 5, because something's going to have to be multiplied by this 2. Okay, so I'm going to have to put numbers, in here. One of them is going to be multiplied by the 2, the other one won't be multiplied, it'll just be multiplied by 1. So for the negative 3, I could have like 1 and 3. One of those has to be positive, one of those has to be negative. So you might just have to do a little bit of thinking work. Okay, how could I get a negative 5? Well, okay, if I do 2 times 3, that's 6. Okay, and if I subtract 1, that's 5. Okay, so definitely it's going to have the 2 and the 3 have to be multiplied. Now, you notice if I put a number here, these two are never multiplied with each other. So if I know 2 and 3 have to be multiplied, they have to be in separate sets of parentheses. So the 3 is going to have to go in the other set of parentheses where the 2 is not, and the 1 is going to have to go here. Okay, so in order to get this negative 5, I'm going to need a negative 6 and a positive 1. So I need a negative here. That'll give me the negative 6. And I need a plus here to give me a positive 1. So let's check that. That's 2x squared, like I need. Negative 6x plus x, that's negative 5x. And then the negative 3. Okay, so that checks out. All right, and so we know that either the factor 2x plus 1 is equal to 0, or the factor x minus 3 is 0. Let's do the second factor first, because that one's a little bit easier. That's x equals 3. Okay. This one, we would subtract 1 from both sides, and that would give us 2x is negative 1, and then divide by 2. And so we would get x equals negative 1/2 for that one. Okay. All right. This one, Okay, it's not a trinomial, it's just a binomial. Okay, so we're not going to have necessarily two sets of parentheses on this one. What we're going to need to do is try to factor out a common factor. So one thing we'll notice is that this has an x factor and this also has a factor of x. So we could take that x and factor it out. Okay, so x times what is x squared? Well, that's x times x. And then x times what is negative 4x? Well, that would be negative 4. Okay, so now, distribute that and let's make sure we get that back. So x times x is x squared, and x times negative 4 is negative 4x. That checks out, that works. Okay, and now once again we have two factors. We have x, so either that factor x equals 0, or this factor x minus 4 equals 0. And what would make that factor 0? Well, that would be when x is 4. All right, and this last one. Okay, now that might look like, oh, well, this is very similar to the last one. We should just factor out the x. But notice the difference between these two problems. Here we have it equals to 0, and here we have it equal to 24. So if we went and factored out the x times x minus 5 equals 24, well, we can't do what we did up here. There's no 24 product property. There's only a 0 product property. And so, that's not really going to be helpful to us because we only can use the 0 product property when the product is 0, not when the product is 24. So if we have a constant over here, we need to turn it into a problem like, this or like this, where all of the terms are on the same side. So we want to subtract 24 from both sides and turn this into x squared minus 5x minus 24 equals 0. Okay. Our goal is to have a product equals 0, and that only works when the product is 0. All right, so now we have a trinomial, and we'll try to factor that. Okay, so what numbers can multiply to 24? Okay, and because this is a negative, okay, they would have to subtract to be a negative 5. So let's think about the factors of 24. That would be like 1 and 24. 2 and 12, 3 and 8, 4 and 6. So which of those, when subtracted, could we get a negative 5? Okay, well, hopefully it's pretty clear that that would be 3 and 8. Okay, so let me put my x's in here. So if I wanted to get a negative 5, I would need a negative 8 and a positive 3 to get negative 5. So I would need a negative 8 and a positive 3. Okay. And so, the first factor, how can I make that 0? Well, that's when x is 8. And the second factor, I can make that 0 when x is negative 3. Okay. So hopefully that is a good review of using factoring to solve quadratic equations. All right, the next set we want to look at is solving by square roots. Okay, so let's look at this first problem. X squared minus 16 equals 0. Well, we know that's a difference of squares, and we could factor it like we did on this previous difference of squares, like the x squared minus 36. But there's another way that we could solve that as well. So there's no x term at all, and so we could go ahead and add 16 to both sides and turn this into x squared equals 16. And then we could just take the square root of each side. Now that's really helpful because the square root of x is x, right? And so we would isolate that x. Okay, so when we take the square root of this side, we get x. Okay, now the issue is, when we take the square root, there's actually two square roots of 16. There's positive 4, because 4 times 4 is 16, but there's also negative 4, because negative 4 times negative 4 is also 16. So when we solve by square roots, we have to be very, 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 very careful to put both the positive version of the square root and the negative version of the square root. So this would be plus or minus 4. There's two solutions. Okay, so factoring is really safe because it will always give you the two solutions. This one seems a little bit easier to do, okay, but you have to remember your plus or minus. So we just have to be disciplined and make sure we remember our plus or minus. Okay. Okay, this one we see is very similar. There's no x term, there's no linear term. And so we feel like we probably just want to take square roots. But before we do take a square root, we have to clear off this leading coefficient here. So we would divide both sides by 2, and those cancel, so we get x squared equals 36. Okay, and so we would take the square root of both sides, and we would get x equals, and we would never forget that we have both a positive and a negative version of the square root. So that's plus or minus 6. Okay. This next one, x squared plus 8 equals 5, is very similar, but we need to isolate that x squared. So we would subtract 8 from both sides, and we would get x squared equals negative 3. Okay, now this one is a little bit tricky. Like when we take the square root of x squared, we get x, but what about when we take the square root of negative 3? Well, a positive times a positive is positive. A negative times a negative is positive. We can't actually multiply any real number by itself and get a negative number. Okay, so if you have a square equals a negative number, there isn't a real number solution to that kind of a problem. So this would just have no real solutions. Now next year you'll learn how to find solutions that aren't real, but we'll save that for next year. Okay. Over here, this one is written as a perfect square equals 49. Now you might be tempted to just multiply this all out, but this really, if you think about it, is in a form that's similar to these other problems where we've got a perfect square equals something, or this one, a perfect square equals something. So just like we could take square roots of both sides for these two, we could also take square roots of both sides here. And when we take the square root, let me just put the square root of this side and then plus or minus the square root of that side. Well, the square root just undoes the squaring, so this becomes x minus 3. Okay, and over here we get plus or minus 7. Okay, so what that means is that x minus 3 could be positive 7, or that x minus 3 could be negative 7. So if we solve this equation by adding 3 to both sides, we'll get x equals 10. And if we solve this equation by adding 3 to both sides, we'll get x equals negative 4. Okay, and so let's check that. 10 minus 3 is 7. 7 squared is 49. If I put a negative 4 minus 3 is negative 7. Negative 7 squared is also 49. So both of those are solutions. Okay. All right, and one more of these. All right, we have this equation, and we might feel like we want to bring everything over to one side, subtract off the 8, and then factor. But you might also look at this and observe, like, hey, I could factor this, and I could factor, and it would become x plus 2 times x plus 2. And I would have a perfect square, and it would be very similar to this problem that we did up here. Okay, so if I rewrite this as x plus 2 squared equals 8, now I can take the square root of both sides, and I'll get x plus 2 equals plus or minus 8. Sorry, square root of 8. Okay. Let's simplify the square root of 8. That's x plus 2 equals plus or minus 2 times the square root of 2. Okay, and then to isolate x, I want to subtract 2 from both sides. Okay, so what do we have left over here on the right? Well, I have a negative 2, and then I have plus or minus 2 square root of 2. So the way that we're going to write that is I'm going to take this negative 2, put it first, and then I'll have the plus or minus in the middle, and then 2 square root of 2. Okay, it can be a little bit confusing to write plus or minus 2 square root of 2 minus 2. We like to have the plus or minus in the middle there. Okay, so always put the plus or minus in the middle when you write your solutions. Okay. All right, the very last technique that we can use, or that we're going to cover for solving quadratic equations, is using the quadratic formula. Okay. And so when we are going to use the quadratic formula, we always want to put our quadratic equation into what's called standard form, where we have everything on one side equal to 0. Okay, so standard form would be ax squared plus bx plus c equals 0. Okay, because the quadratic formula uses the a and b and c, and so it has to be in that form for us to know what a, b, and c are. So in this particular instance, our a is 2, our b is 7, and our c is, okay, there's a negative in front, so it's going to be negative 4. Okay, this has a positive in front, so it's positive 7. This has a positive in front, it's positive 2. Okay, and then we know then that the quadratic equation, or the quadratic formula, gives us x equals negative b plus or minus the square root of b squared minus 4 times a times c, and that whole thing over 2a. Okay, so for this particular problem, negative b would be negative 7 plus or minus the square root of b squared is 7 squared minus 4 times a is 2, times c is negative 4. And that whole thing will be over 2 times a is 2. Okay, so we're going to get negative 7 plus or minus the square root of, well, 7 squared is 49. Okay, and then we'll have 4 times 4 is 16, times 2 is 32. It'll be a positive 32. 2 times 2 is 4. So that's going to be negative 7 plus or minus, and that's going to be the square root of 81 over 4. Okay, I'm kind of running out of room here, so I'm going to go this direction. Well, the square root of 81, yay, we know that. That is 9, so that's negative 7 plus or minus 9 over 4. So there's really two solutions. There is the negative 7 plus 9 over 4 solution. That's taking the plus. And there's the negative 7 minus 9 over 4 solution. Okay. Negative 7 plus 9 is 2. 2/4 is 1/2. So 1/2 is one of our solutions. And then negative 7 minus 9 is negative 16 over 4. So negative 4 is our other solution. So 1/2 and negative 4. All right. So this one on the bottom, notice that we don't have everything on one side of the equal. So we would need to subtract 8 from both sides and turn this into 6x squared plus 8x minus x equals 0. Okay, and then we would see that a is 6, b is 8, and c is negative 8. Okay, so then we could put that into the quadratic formula. So x would be negative b, which is negative 8, plus or minus the square root of b squared, that's 8 squared, minus 4 times a, which is 6, times c, which is negative 8, all over 2 times a, which is 6. Okay, so those are really big numbers, and we could go ahead and do that. But one thing that I notice is that this is an even number, this is an even number, and this is an even number. Okay, so if you see that all the coefficients are divisible by the same number, it might be a good idea, instead of dealing with this, to, instead of that, say, all right, hey, well, I could multiply both sides by a half, right? I could do half of that. And if I did that instead, I would get 3x squared plus 4x minus 4 equals, well, half of 0 is still 0. Okay, so this is going to give me a much simpler equation because I'm going to have a is 3, b is 4, and c is negative 4. I'll get the same answer, okay, but I have these smaller numbers to work with. So if you ever see something like that, you definitely want to try to, multiply and get the coefficients down to be smaller. Because this one will give us x is equal to negative b, that's negative 4, plus or minus the square root of 4 squared minus 4 times 3 times negative 4, all over 2a, that's 2 times 3. Okay, so we're much less likely to make mistakes with these smaller numbers, so that's the way to go on this kind of a problem. So that's going to be negative 4 plus or minus the square root of 16, and then we've got 12 times 4 is 48, so that'll be plus 48 over 6. That's negative 4 plus or minus, let's see, that's 64, the square root of 64. Alright, so that's really 8, right? So we've got negative 4 plus 8 over 6, and we've got negative 4 minus 8 over 6. So this one is 4 over 6, or 2/3, and this one is negative 12 over 6, or negative 2. So 2/3 and negative 2 are our solutions there. Okay. Alright, one last problem up here. Like this would be way easier to solve if we just factored out the x and used the zero product property, but let's just also show that we can use the quadratic formula for problems like this as well. So is this in standard form? Well, ax squared plus bx plus c, our a, what's that? Well, there's an implied coefficient of 1 here. X squared means 1x squared, so a is 1. B is 20. And c, what's c? Well, we could easily just put plus 0 here and not change anything. It would mean the same thing. So c is 0. Okay, so when we use our quadratic formula, we're going to get x is negative b, that's negative 20, plus or minus the square root of b squared, which is 20 squared, minus 4 times a times c, all over 2 times a. So we're going to get negative 20 plus or minus, well, this is just 0, and the square root of 20 squared is 20 over 20. So I would get negative 20 plus 20 over 2. Over 2. So negative 20 plus 20, that's 0. 0 divided by 2 is 0. And then negative 20 minus 20 is negative 40. Divided by 2 is negative 20. Okay. So those are our two solutions there. Okay. And notice we could have easily gotten that by doing x times x plus 20. So x is 0, or negative 20 would give us a 0 on the other. That would be a much simpler solution, but at least we can verify that the quadratic formula does indeed give us the correct answers, even when we have like a c value of 0, or we could have a b value of 0, and it would work as well. Okay, so that is our quick review of solving quadratics. And so you can work on the problems on your worksheet, and we will continue working on those after we get back from our break as well.